Learn beyond the infinity. Future starts here.
Hello everyone, welcome back to Quantum Explorer. In today's video, we will discuss about sorting part 1. There are many types of sorting like selection sort, bubble sort, insertion sort and many more. In this part 1 video, we will talking about selection sort, its pseudocode and about time complexity. Let's begin. In selection sort, what happens? As name suggests, select. I will select minimum element from array. What it means? Let's say I have this array. What I do? I found minimum from this array. As we see in this array, minimum is 8. Then what will I do? I swap this 8 with the 0th index of this array. Then how this array looks again. This array looks like 8, 39, 17, 64 and 23. This is my first step. Again, what will I do? I iterate in this whole array and again find minimum. But in this time, I not start from 0th index. I start from first index and iterate till n minus 1's index and find the minimum. It means that I divide an array in two parts. One part which is sorted after step and second is remaining part. After first step, the sorted part is the only 0th index and other are remaining part. So in this part I will find minimum and that is 17. So what will I do? I will swap this with 0th index of remaining part but first index of original array. What this means, I swap the 17th with first index of original array and at the end of my second step my array looks like 8, 17, 39, 64 and 23. Step. This array is sorted and this array is remaining. So what will I do? I iterate in I iterate from second index to n minus 1th index and find minimum. Here minimum is 23. So what I do? I will swap this 23 to my second index. In the third step my array will look like 8, 17, 23, 39 and 64. After end of third step, my sorted array is this and remaining array is this. What will I do next? Again, I iterate in this array, find minimum. Here the minimum is itself at its correct position. So at the end of my fourth step, I will get my sorted array. This is the algorithm of selection sort. In selection sort, there is few step is select minimum, swap with respective index, index. Means in first step, swap with 0th index. Second step, swap with first index. Third step, swap with second index. That type. And repeat. This is a basic algorithm of selection sort. Let's write code to understand more it. Let's write code to understand it with more clarity. I have int function, int main. Inside this, I declare an variable n, then take input from user of n, declare an integer type array of size n, and take input from user of array. Then I will call my function which I make here is with selection sort ss, which take integer array and n as a parameter. Inside my main function, I called this ss as array taken from user and number of elements. Then after completing this function, after calling this function, I again print array in output to see if my output is correct or not. Okay, now it's time to write a logic inside this selection sort. How it works? First of all, as I say, what this algorithm is, select the minimum. So we will find the minimum inside this array. First of all, we understand how to find minimum from an array. Let's say I have same example of previous array. How I find minimum from this array, which has elements n and length is n minus 1. How I find? Initially I suppose that the 0th index element is minimum. I know it might correct or not, but I suppose that it is the minimum element. Then I declare temporary variable integer minim. Its array of 0. Then I iterate in this entire array. For int I is equals to 0, I less than n, I plus plus. In entire array, every time I check if my array of I is less than minimum, then what I do? I say that now my minimum is array of I. How it works? Initially my minimum is 23. My for loop iterate in all elements in array. It first of all go to 39. Is 39 is less than 23? No, this condition is false. Is 17 is less than 23? Yes, this condition is true. So now my minimum, instead of 23, it will become 70. Then I further loop iterate. Loop iterate is 64. Is 64 is less than 73? 13? No. Again loop go further. Is 8 less than 17? Yes, this condition is true. And again my minimum, instead of 70, it will 8. So at the end of this loop, I will find the minimum from an array. You need to understand this. When I swap first time the minimum element with my 0th index. Swap my minimum element with 0th index. I iterate from 0 to n minus 1 because my length is n, then index is n minus 1. When again I swap my next minimum element with first index, I iterate in 1 to n minus 1. When again I iterate, I swap my second element, I iterate from 2 to n minus 1. When I do third index swap, I iterate from 3 to n minus 1. And you can see after third step, my array is sorted. So what I can say generalize, I iterate, I swap n minus 2 times for, and every time I iterate from my index to n minus 1. So now we can able to write the code. Next one sort. I iterate from in I equals to 0 to I less than n minus 2 I plus plus. Inside this for loop in minimum as my I every time I declare my first element as 0 and I iterate in whole loop which is start from, as I tell you, I to j less than n minus 1 j plus plus, and every time if I found that my array of j is less than minimum, then I update my minimum with j, and at the end of this loop I have my minimum index. Then I just swap it int temp is equals to array of j, then array of minimum is equals to array of I means parenting array of I is equals to temporary. So this is the whole logic behind the selection sort. This swap two numbers logic are available in our YouTube channel, so you can watch out this question as I explain you all logic. Let's talk about time complexity of selection sort. In selection sort, we have two loops. In first loop, we iterate from 0 to n minus 2, and inside second loop, we iterate from 1 to I to n minus 1. But here the thing is that when I add 0 to n minus 2, when I iterate for 0, I iterate from 0 to n minus 1. When I iterate for 1, I iterate from 1 to n minus 1. Means in this time I iterate 0 to n minus 1 time. Here I iterate n minus 2 time. Here I iterate n minus 3 time. So if we add total these things, we iterate n minus 1 plus n minus 2 plus n minus 3 up to 1. So here we can say n into n minus sum of n number, which is n into n plus 1 by 2 n square plus n divided by 2. It is the time complexity. But as I tell you, the concept of time complexity, we neglect constant and we neglect the smaller term less than the higher power term. So ultimately, time complexity is n square and we represent as big O of m.